Good day, everyone. Welcome to Quantitative Methods with Simulation Modeling lecture. Today, we will be talking about descriptive and inferential data visualization. And in this lecture, you will be able to first understand the concept of descriptive and inferential through visualization using R programming. And the second, we'll try to utilize R programming codes in visualizing real-world data. And third, you will try to analyze real-world data through descriptive and inferential visualization. In data visualization for R programming, we will be talking about descriptive data visualization and inferential data visualization. If we say about descriptive data, take note that descriptive research is a type of research that is basically used to describe the characteristics of a population. And of course, it also collects data that are used to answer a wide range of what, when, and how questions pertaining to a particular group or a particular population. While inferential data visualization or inferential statistics, it is actually used to study the probable behavior of a population. And the inferences are basically drawn from the available sample data. Now, once a sample data has been chosen, the researcher can actually apply any tool of inferential statistics depending on the purpose of the research. Now, these are the things that we can do for data visualization in R. These are just some few of of some things that we can perform data visualization for descriptive and inferential using R programming. So we have here the univariate graphs such as categorical and quantitative informations. We can also do some bivariate graphs such as categorical versus categorical data, quantitative versus quantitative data, categorical versus quantitative data. And also for the multivariate graphs, we can do some groupings, pasting, and for maps, hopefully we can do this now. We have the dot density maps. We can do also correlates maps. And finally, we will be talking about statistical models visualization using correlation plots, linear regression, and logistic regressions. If there are some more time, then we can do other statistical models that we can visualize using R programming, right? Now, let's go into the to call this demonstration of our call this of in R, so we can actually to call this practice on the use of R programming. All right. First and foremost, we have to load first our data. In my case, I have a data. I store it in a particular folder in my computer. Say, for example, I'll be using this variable sal for salary. Okay, I will try to read the data in Excel, okay, with the following source. 1, 2, 4 activities. And then we have salaries. Oh wait. Red Excel. This. All right. Let's try here if we can import the the data. Okay, there you go. Okay. All right, so we have here the salaries data. Uh, and instead of using this, we'll just call directly the name of the datasets as salaries. I will pass it through this variable, let's say S variable to make it short. All right, so we'll be using a library for us to be able to manipulate and display some visualization. I'll be using ggplot. If you have not yet installed ggplot2, you have to install it via clicking these tools, install package, and then just right here, ggplot2, and click install. Since I have already, I don't need to install it anymore. Okay, make sure that you have internet connection when you are installing a library to your R Studio. Okay, let's try first doing some univariate graph. Let's try first the first one. We have categorical demonstration. Take note that categorical, basically these are distribution of a single categorical variable that is typically plotted with a bar chart, a pie chart, or a tree map, which all of these we will be demonstrating that in the uh, next few segments of this discussion. Okay, let's start with the uh, bar chart. Okay, so I'll be using ggplot, assuming from this salary, I would like to visualize the rank. All right, the rank of the data sets of this information, such as professor, assistant professor, and so on and so forth. Okay, so name of the data set. Okay, and then the static data that we will be doing, assign it to a variable object as the data from the data set. Okay, and then I will do some geom, which is a reserve function of the ggplot2. All right, so there you go. Now, as you can see here, we have here the graph for associate professor, assistant professor, and professor. All right. So actually, the plot is the plot distribution of rank can be modified by adding some colors to it. So how are we going to do that? So instead of these only, we are going to add in the bar. Okay, we will fill it with colors, as for example, cornflower, blue color, right? What else? We will try to color also the edge as black, right? And then let's try to put some informations at the sides, such as we can have the following. Y as its frequency, and then we have title as data sets by rank. All right, so that's it. Okay, so right, so you'll notice it changed to corn blue with a border black color, and then the rank frequency uh, of the graph is also shown here, and of course the label here at the top. All right. All right, so we have here our graph now. Now, To make it something more clearer, if you would like to know the values of each of these, we can actually put values here at the top of every bar in this bar graph. Okay, so to do that, we are going to do, let's just copy this one here at the bottom. Then I will try to count, no, for example, what's the name? We have here our S as the salaries, all right? So pipe, just pipe, uh, and then we will try to count the rank values here, all right? Okay, and then for the aesthetic, let's try to put in the rank as to the value of your y-axis as the number of data. And then for the bar, we have to fill in same with the statistical values as to all this identity, right? And then for the values here on the all this in the bars, we can ask for the geom text. Okay. And for the geom text, we will be using statistics value as the label at the top, which is the number of frequencies. And, and then we will try to adjust by negative 0.5. All right, I guess that's fine. Okay, so the same, we still have the x-axis as rank, then the y-axis is frequency, then the label is data sets rank. Okay, so let's try to run that. Oh, all right. So I have to use a library, DPL player, DPL YR. So if you do not have yet this library, you have to install that. There you go. All right. And run. So we have here already the values per graph. Okay. Now for the horizontal bar, and for the horizontal bar, for example, you want to flip this one to the side. So all I got to do is actually to flip that. The function is actually to flip. Okay, so for example, for this one here, you can add here coordinate the flip function. Right, so let's try to run again this one. There you go. So we flipped that already to going to this as our for the bar. All right, so let's continue with the this one. Um, let's say for example you want to use a pie chart with the same what do you call this, the same values here for the ranks such as professor, assistant professor, and associate professor. So let's try to use a pie chart to visualize the data. Okay, so to do that, still the same, let's just copy this one here. All right, so run, because that's the one that you are going to perform. Okay, some pipe. All right, there you go. And then we are going to uh, rearrange. Okay, arrange the display by rank. Right, there you go. This. Okay. And then we mutate this. Oops. The prop as round of the number times 100 divided by the sum of n. Uh, 1, and then log dot the y position, okay, is equals to sum prop minus 5 times prop. There you go. Check. We have here the mutate. This one. All right. And then this. This. All right. Let's try. There you go. Mhm. Mhm. Let's check whether these range tests. Okay. Oh, all right. There you go. One more. Oh, there you go. Unexpected in the next. Mhm. So we have here salaries, count, rank, rearrange tasks. Okay. Rearrange tasks. Where is it? Desk here. So arrange tasks, mutate, unexpected. Ito. Ito siya. Why? Like that. One. There you go. Okay. And so we can now manipulate the data. Okay, so we have GG plot S, and then yes, we have X coordinate, and Y is equals to prop. And then we fill it with trunk. All right. Then with our geom bar, yes, the width is 1. Stat is equals to identity, and then color, let's say black. All right, and then we add some coordinations, a polar coordinate. Right, so we have, sorry, y, okay, and then start from 0, and the direction is to -1. Okay, and then we have the theme, void. Let's try this and run. There you go. So we have here already the pie chart of our ranks positions. Okay. Now let's try to label now some, and we try to remove this legend, and we just rather label here the, we call this the values here. Okay. So we have here, still we are going to copy everything, but we are going to add some we call this some values here. Okay, so after here we can have our um we can just add here some label. All right, so we have the data, which is S as salaries, and then we will call label as the variable, and then we paste 0 as S rank, of course. All right, so we have here slash n, the next line. Okay, then we have round S, sorry, S prop, and then it will be in percentage. Okay, let's try to run this again. All right, so, oh, we have not yet used the data here. So let's try to check S with static and profile is rank. Gym bar is one identity, then the color is black. The coordinate polar is y star from 0 to direction -1. And then theme is void. Let's just add the values here. We have here theme legend, okay, equals participant by rank, sorry, not participant, but that's for the legend rather. Legend position will be false. Okay. And then we have here labs title. There we go. I think that will be fine. Let's try to run. All right, there you go. Let's try to run again. Put the value with the label and put it in the table. Oops. So S dollar label paste S rank. So let's try to check S paste 0 the value dollar rank slash n, and the round of dollar channel slash n. Oh, oh, whoa. Select the dollar paste is dollar label. Mhm. Let me check the label. Mutate rank disks. Data dollar label. And so we have here the label. Bakit siya ayaw mag-work? Let me just change this to S. Um, It will work, but there's no such thing as no tasks. Mhm. But ayaw niyang mag-work. Counter rank round of dollar and some one y position from some prop equals 5 times prop. Okay, man. Then we have here the level-based speed data rank. Um, s- Bakit ayaw niyang mag-work? P data not found. Nasaan si P data? Ayan. Sorry. There you go. Oh. Mhm. Mm. Wait a minute. I have something. I missed something. Data. All right, there you go. So I think I missed a code here. Oh, there you go. So we have here 67%. Okay. Hmm. Okay, so now we go to the tree map. So what we got to do is to up here to use some tree map, assuming we are going to use a library tree Mapify. So if you do not have this, all you got to do is to for that to uh, download it. Okay, so I will be using still P data, but this time I will not be using anymore the salaries, but rather I'll be using the MPG. Okay, so if you want to know about MPG, you can actually put a question here. So what is MPG? And so it will give you the data about MPG here. Okay, so I got to this to understand here. So these are the informations about the fuel economy data from 1999 to 2008 for the 38 popular models of car. Right. So this time, so let's just use that as our example. The same, still we have to do the pipe and then uh, count. Let's say, for example, the manufacturer of this. Oops. Uh, in a while. In, manufacturer. There. So there are 15 observations of two variables. Okay, so this time we are going to use ggplot. We still use the P data. Then we have here the statistics. So we fill it with colors by rank. And then the area will be equal to the total number of data. And then we have here the geom tree map. Okay. And then we add informations here as our title. Let's say, for example, these are about the fuel economy data by let's change this to manufacturer. by manufacturer. I think that is enough. There you go. So you will notice here the fuel economy data by manufacturer. So these are the manufacturers and with their tree map color. So let's try to add some informations here and put this here inside so that we will be able to know more further about this particular area. All right, so to do that, so all you got to do is to do again with your data. Okay, let me just copy this. Let's try to put some label to the tree map. So just still copy and paste data. So manufacturer area, and then we label some the manufacturer. Right. And then we have tree map. And then we have the geom tree map X. Okay, so we have here the colors or color. Let's say just white. Then we have here place center, or yeah, guess it's okay. So labs manufacturer. Let's just add some spin. So we have legend position. Um, no. Right. There you go. So we have here. So the first two who occupies the most number are Volkswagen, Toyota, Dodge. Then next to that is Nissan, Subaru, Audi, Ford, and so on and so forth. Okay, so we're done with the categorical variables. Now let's proceed to in the part of quantitative for a single quantitative variable that is typically plotted with the histogram, kernel density plot, or the dot plot. So we'll be doing some histogram and kernel density plot because the dot plot is almost the same with the bar chart. All right, so still we'll be using uh, okay. Still we'll be using the same data. So we have here library, ggplot2 in case, then you have to run it. Still the same, we will be using mpg. So for easy manipulation. And then so we have ggplot2 values, the data, okay, the static data informations, of course, x is equals to HWY, the highway per gallon data. All right, there you go. Okay, so we have geom. Histogram. Labs. The title can be about participants. Highway miles per gallon. The HWY. Okay. And then the X will be about the highway miles per gallon. Okay. All right, so let's try to run that. Mm. Yeah, yeah. Oh, all right. So sorry. So put it there. Oops, GG plot. Mhm. There we go. Um, So we have here the quantitative distribution of our data using histogram. Now you can actually put colors on it. By just putting here fill, uh, fill corn, flour, and what else? You have to put some color of the data as white. There you go. So it changed into something different from the one that you saw. Okay. So this time we'll be talking about kernel plot. Kernel plot actually is another way of presenting the data. Okay. It's much more professional, for example. So it's still the same. We will be using the same data here, but instead of histogram, we'll be use the density of the kernel plot. Okay. So just run it. So you have here the representation of the graph of using kernel data. And actually you can put some colors in it by putting some, of course, the geom density. Same thing here that you did, right? So you can just put it here, right? Or yeah. Sorry. Oops, not fill but fill. There you go. All right. So, or if you want to change this color into a different one, let's try some red. Mm. Oops, sorry. Well, I forgot to put. There you go. Okay. So that is for the kernel density. Instead of using just simply the histogram, you can do some density, the use of density, right? So that's all for the univariate description of quantitative descriptions. Okay, for both categorical, okay, and at the same time for quantitative distribution of data using histogram and density, or the use of kernel density plot. All right. So thank you very much for listening. We will have another set of discussions for more about descriptive and inferential data visualization in the next few days, in the next few meetings rather. Okay. Thank you so much, and perform the activities that we will be uploading in the Google Classroom. And for this time, I would like you to uh, perform this, okay, in your respective computer, but this time instead of just simply using the MPG as your data, okay, still MPG as your data, but you are not going to use anymore the manufacturer and the highway. But this time, I want you to work on class and the and displacement. All right. So work on class and displacement using the MPG dataset by performing the data, the things that we did here for doing some bar chart, right? Both for categorical and for quantitative distribution. Okay, that is for your activity for this session. All right, so submit your activity in our Google Classroom by submitting first the source code and then the screenshots of this output here should be presented in your in a Word file with a short description of what do you observe on that graph that you have created. Okay, make a short description of no less than 5 sentences per chart. Okay, in-depth description of the chart. All right. So the topic about this is on the class and displacement. Okay. Thank you very much and see you again next time.